Hi guys, this is Srinath and I'm going to be talking about the applications of context-free grammar using speech recognition. Context-free grammar is defined by a quadruple. Grammar is equal to V, the set of variables, E, the set of terminals, E, the productions, and S, the start symbol. The productions are used to derive one string over another string. Context-free grammars are formal language models that define a syntax of a language through a set of production rules. The automatic speech recognition method is of two types: spelling correction method and text matching method. They play a crucial role in speech recognition. Basically, it provides the necessary structure to parse and understand spoken language. If alpha to beta is a production in a grammar, then we can replace alpha by beta in that string. The role of the context-free grammar in computation linguistics. In speech recognition, there are roles that it takes place. Language modeling. CFGs can be used to define the grammar and syntax rules of a language, which enables robust language modeling for speech recognition and natural language processing. Parsing. The CFG based parsing techniques can help to analyze the structure of the utterances crucial for understanding the context of the spoken language. Domain specific applications are banking and healthcare. Healthcare is used in enhancing the performance of speech interfaces in those contexts. Error correction. CFGs help and identify grammatical errors in user input and improve the accuracy of speech recognition systems. These play a major role in error detection and error correction. Error detection is detecting the error, and error correction is helping to correct the error. The applications of CFGs in speech recognition. CFGs have many applications. They're used in speech recognition, natural language processing. The CFGs are used to model the syntax of spoken language, which enables the speech recognition systems to interpret the natural language. Parsing algorithms based on CFGs will help in the identifying the structures of spoken words. This allows an accurate interpretation and transcription. The CFGs can be leveraged for error detection and correction in speech recognition, identifying and fixing grammatic or semantic inconsistencies. Language modeling with context-free grammars. There are three types of language modeling that takes place: formal grammars, contextual understanding, and probabilistic modeling. Formal grammars provide a formal and structured way to define the syntax of a language. It enables precise modeling of the speech patterns and provides improved accuracy. Contextual understanding. The CFG-based language models can capture contextual dependencies, which helps in improving the accuracy of speech recognition by considering co-occurrence patterns. Probabilistic modeling. It depends on the probability of the grammar rules. The CFGs helps in building statistic language models that predict likely word sequences. Parsing with CFG-based approaches. Parsing with context-free grammars is a very important concept in speech recognition. It helps in analyzing the spoken words, which helps in identifying the grammatical relationships between words and phrases. It is a vital step in transforming speech into text. By leveraging the hierarchical nature of CFGs, the parsers can help in breaking down complex sentences into their constituent parts. It's an improved language modeling for enhanced speech recognition accuracy. Error detection and correction using CFGs. This is the most important part in context-free grammar to detect and correct the errors. Modeling grammar. The context-free grammars are used to model the structure of the grammar, which helps in capturing the sentence structures. Detecting errors. By parsing user input, it can help in identifying the deviations from the correct to from the incorrect to the correct. Suggesting corrections. The CFGs can help in guiding the system to suggest corrections for the intended grammatical structure. Grammar-based speech recognition. The grammar-based speech recognition helps in context-free grammars to model language structures and semantics. This approach allows for precise recognition of complex domain-specific utterances by constraining the search space and enforcing grammatical rules. For example, Google uses Google Assistant, where you can speak and it recognizes your voice and converts it into text, and you can search about it. The grammar-based approach is particularly useful for applications with well-defined vocabularies and linguistic patterns, like command and control interactions or task-oriented dialogues. This is used in iPhone, you like Siri, Bixby with Samsung, etc. Integrating CFGs with statistical models. This is one of the most important part in speech recognition. The data analytics process is of six types: data evaluation, deployment, business understanding, data preparation, data exploration, and data modeling. Statistical models and context-free grammars go hand in hand and are two powerful approaches used in speech recognition by processing. By integrating these two complementary techniques, researchers can develop hybrid architectures that help in identifying the strengths of each to improve the accuracy and adaptability. Complementary approaches. There are three types of complementary approaches that are used. Which are statistical models, which help in enhancing the capturing the patterns in large data sets, and it's used in language modeling and machine translation. The CFGs provide a structured, rule-based framework for representing the syntax and semantics of natural language, which makes it more interpretable. The integration. Basically, integrating the statistical model and the context-free grammar helps in more powerful and versatile language processing systems. Hybrid architectures. There are three types of hybrid architectures that are used, which are probabilistic CFGs, neural CFGs, and constraint decoding. The probabilistic CFGs incorporate statistical probabilities into CFG rules to capture uncertainty and ambiguity in natural language. There are many ambiguities that can be found in context-free grammar. This is used to identify and help in correcting the ambiguities. Neural CFGs. The neural CFGs are combined into deep neural networks to learn rich contextual representation of the language. Constraint decoding. Using CFG-based constraints to guide the output of statistical models. It helps in enhancing and ensuring grammatical and semantic coherence. Basically, there are two layers in this: the original layer and the hidden layer, which go hand in hand. Improved accuracy and adaptability. This is the main application that is used in speech recognition. It has three types: enhanced interpretability. The hybrid models they provide a better explanation for decisions and make it more transparent and trustworthy. Robustness to noise. The structured nature of CFGs can help statistical models handle the noisy or disfluent language more effectively. It is also used in adapting to new domains, which is the future. The modular design of our hybrid architecture helps in fine tuning and adapting to specialized tasks and data sets. Domain specific grammars for speech recognition. There are four types of domain specific grammars. They are customized grammars, medical vocabulary, aviation lingo, and smart home commands. The domain specific grammars are tailored to the unique vocabulary and sentence structures used in a particular industry. Medical vocabulary is used basically in healthcare applications, like on healthcare app, which helps in specialized grammars, providing medical terminology, drug names to enhance performance. Aviation lingo. Aviation lingo grammars include aviation specific terms, call signs. For example, nautical miles. To accurately transcribe air traffic control conversations and pilot instructions. Smart home commands. Home automation grammars will help in recognizing natural language commands for controlling smart devices, applications, and home systems, which provide a seamless voice based user experience. For example, you can control your TV using your voice. Conclusion. To conclude, we can say that the context-free grammars have emerged as a powerful tool in the realm of speech recognition, which enables more accurate language modeling, robust parsing, and advanced error detection and correction. This helps in embracing the future as speech technologies continue to evolve. The role of CFGs will only become more crucial, paving the way for more natural, intuitive, and accessible voice interfaces. Thank you.